Alright, it's been about a month and been doing a bunch of stuff. One thing I was playing with is the Slither bot. So I think where we last left off, the Slither bot would basically randomly go around the screen in the game, and if it died, it would start over again. And it would pretty much do this forever. So what I've done is made basically the foraging mode that it runs in a little bit smarter. So added a couple extra files, but this is the file we use to fire it up. We still have the bug to where sometimes it won't start. You still have to manually get the game going, and that's a little bit of a pain. So you run it, and let's say this, and go. So if you don't see the mouse immediately start randomly moving around, then it's in this mode to where the code's not autonomously doing anything, and I'll still have to figure that out. So what I do is I kill myself. It sees this play again, moves the mouse, and clicks. So now it will run forever. And the difference is that on the upper left hand side of the screen, that's the actual game, and it doesn't have collision avoidance. It doesn't understand what worms are or anything like that yet. But now what it will do, if you look at the lower or the middle of the screen, you're going to see this yellow dot. And every second, it's going to take a picture, screen capture. It's going to run the algorithm to find all the food pellets. And then it's going to calculate, based off of its direction, the target food pellet it's going to run towards. And right now, this is kind of handcrafted, and it was getting stuck. Sometimes it doesn't see food pellets, like right there. And what'll happen is the code will say, okay, this food pellet is so close to me that it might be my head. So just randomly move the mouse. So now that got a little close, that's further away, and you can see it's going to go, for, this food. Now, it doesn't understand clusters or what are the best areas it should, in a cluster, it should go for. I'm just trying to get the code to where it's doing what it's doing, where it's growing. And right now, you can see in the upper left-hand side on the little radar, it's pretty close to the edge and dying. But it is collecting food pellets, or food, whatever you want to call it. And then if it can't find anything, it randomly goes around. So also, you could see the score. It's doing relatively good because there's no competition right now. If it was in the middle of the screen or middle of the world, it'd get obliterated by all the competition from all the other worms. So there's going to be different states that this little guy goes into. One is, there aren't any threats around, so I'm going to forage. And as the threat gets higher and higher based off of some other algorithm that I haven't written yet, then it will go into a defensive, mode. And that's about as far as I got it right now. I'm going to check this code in. And as you can see, boom, it's going to die because it has no clue, but it got up to 254. We'll see, now it started further on out where there's less, food to eat, but there's less predators. But it is targeting points to go to, and that was kind of a major accomplishment for me as far as Python and mathematics. So since the mouse is in, the code is controlling the mouse, it still makes it hard to shut this thing down. But the trick is if you hit Alt Tab and you tab over to the second window, then hit Q. Let's see, yeah, it killed it, and then you come up here and you kill it. Okay. There's a couple of optimizations I want to make. This screen capture code is happening in a lot of places to where it's grabbing the entire screen, and that can happen one time based off of the area that we're trying to capture. This is the score, and that has different coordinates here. So this is a different type of screen capture. But what would be nice is I make it to where it just captures the entire screen, and then these other pieces of code we slice up based off of it's trying to read the score. Now, I've fiddled around with the score reading, and this Tesseract thing, it just can't do it. It can do it with obviously with this skin image, but I'm going to eventually replace this with something else that's much more robust. The skin image could be some object detection training or something like that. The score is a little bit different because it's a font and it's constantly changing. Anyway, we can kind of scroll down to the bottom and then go back up to the top. And currently we're using the Chrome. I had to update the Chrome driver because Chrome changed its version. And in the other video, I show how you can go download the Chrome driver so we can, get the screen to pop up, Chrome itself. Probably don't need that anymore if there's a command line. I think there is to run Chrome and tell it the window size, but then you'll have to rework a lot of this code. So let's see, up in here we go in this loop, is dead, play again. These are the ones that are basically making the decisions on whether it thinks it sees the skin image. Then we sleep, and this moves the mouse to click, and this code works. And if we're playing, basically this code is checking every second. We hit second or 1 second, then we find the food using the last direction, and it should calculate a new direction. If it doesn't, no food, and then we just do a random direction. So the direction's set, and then we move to that direction, and then we get the last direction, and here's the key. So that's relatively simple. Move to radians. That's pretty simple. The other fun part of this code is in, I think, find NN, which I got some of this off of the internet, I will confess. Let's do find nearest neighbor. I had to tweak it so it would work. And this code seems to work. I pulled these lines out, find points. this seems to still work. And then to calculate direction, not sure what I'm using here. So we go find the food, do a whole screen grab, just doing the shape of the width and height so we can find out what the center point is, but we probably already know that. But anyway, and then from that screen grab, we find the points, we get the length. If it's less than 3, we just return. Do a little bit of maths, and based off of the last direction, we're going to try to calculate from where we're at, plus a radius of 75, our target X and target Y. We turn this into a tuple, and then from that target, we find we don't want to necessarily use ourself. We want to use what's further out from us, and then we go, okay, get all the other points based off of this target point, and this is the point that is the nearest. I do a calculation again on how far away that target point is, because that target point might be so close to us that it screws the algorithm up. I do go through all the circles, and based off of the food, based off of their distance, if the closest one of the target that we want, which is here, the index of this point, that one's yellow. So all this code's doing is going back through all the points and then changing their colors. I was trying to get it off of a gradient, but what it's doing right now is the darker ones should be brighter, and they're not, and I'll have to figure that out, and we have to clip them. So that way, this other screen that appears, we can see where the worm is going to go. So this find food has some graphics debugging information in it, so we can see what's going on. And then I also clip between greater than us and less than the target distance to kind of give us a little window of and then calculate the new direction. If not, it's a random direction. So this seems to be working relatively well. Again, there's still some bugs. There's no neural nets or machine learning in the code yet, because I don't really know how to gather all this information and do that yet. So I'm still pondering how we're going to do that. Let's see, did it take? Okay, see now it randomly, it just worked. So this thing will sit there and run forever. And that's why I was trying to get the score to work, because it'd be nice to keep a tally of the highest score. But with the, of course I'm pointing at the screen, you can't see the screen, I can't use the mouse anymore. It says, your length, and the OCR software just has a real problem with that. I did discover a Keras TensorFlow OCR library that I'm interested in using to see if we could potentially use it instead. The Tesseract is just, it's real picky. So there you go, 96, keeps going. I just thought this was cool. I play this game a lot, trying to get my brain going. And as I'm playing the game, I'm thinking of ways of how to do the next step, which is if it sees predators, it tries to run away or get away from them. It goes out of food foraging mode and goes into this other, survival mode. One idea I thought might work out is to have just figure out where the little gray octagons are that don't have any food particles in them. And if the food particles could also look like, as you could see on the other part of the screen, dots. Now, again, there's another algorithm I can use and fuzz up, and it's the hue circles, and maybe we could use that, but that's kind of the next step. So just try to get it to survive, go out of trying to eat and go into a circle. I've seen bots running inside of Slither.io, and they're relatively intelligent. They don't look like they have any food foraging capability. They're just kind of putting around, but they will go into this survival mode, which is kind of interesting. So after that, after a couple weeks, if I can figure that out, then maybe we can go into attack mode. And that would be, kind of interesting as well. So let's see, we do Alt, Tab, 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 Q, boom, it's dead, kill it. And that's it. So I do have some other exciting news with the metahumans coming up. I'm probably going to make another video on that back to back and give you guys some happy Thanksgiving, content to play around with. So that's all I've got right now. Making some progress on this. I think it's a fun little project, and it'd be neat to get the Slither.io automated to the point to where it could be a formidable adversary. So other than that, have a great rest of your life until the next video, and thanks for watching.